here we have to find the area of the image, and before going to solve this one, I remind you that what do we do when we calculate the area in xy plane. If you remember, then we do a double integration like this, dy dx double integration, and limits we take according to the case. So here we do the same. So what you observe here, we have taken the y coordinate, differential of y coordinate into differential of x coordinate. You may say differential of second coordinate into differential of first coordinate. So accordingly I do here. You see the second coordinate here, this thing. So I take differential of that, d pi by 2 1 minus s. Okay, this thing is clear to you. And differential of the first coordinate, and that is pi by 2 s 1 minus t. Okay, and double integration, and there will be limits as well. I will write those limits later. First we simplify this one. You see pi by 2 2 times are constants, so we can take these two out, and this will be pi square by 4. And now inside it remains 1 minus s and d s 1 minus t. Okay, so this thing is st coordinate. Okay, and if you observe the first one, I think this one, then it is simple, because in this you see only one variable, that is s. But when you observe the second, here in the second it is s into, here it is s 1 minus t. So it is complex, because here it depends upon s as well as t. So we will have to use the Jacobians, and I think you have studied about the Jacobian. According to that, I have to transform this st coordinate into some other to get the result in a short time. For that, I assume this to be u and this to be v, and you know the Jacobian then will be j equals to del u by del s, del u by del t, and here del v by del s, del v by del t. Okay, so let us calculate del u by del s. This will be obviously 1 minus t, del u by del t, this will be minus s, thereafter del v by del s, this will be minus 1, and the last one del v by del t, it will be 0. So determinant of this thing will be minus s. Okay, so our Jacobian So our transformed double integration will be mod j and mod j dv du. Okay, let us write the value of j, mod j, and you see j is minus s, so mod j will be minus s and this will be s. And if you see here I show you in green here, if you see here in the green enclosure, then s will be 1 minus v. Okay, so this will be 1 minus v. So here this will be 1 minus v at the place of mod j, and here will be dv du. Now the time comes for the limit. How can we put the lower limits for both the integration and the upper limit? So first see here, you see s and t both are independent. Okay, both are independent, so that's makes the thing easier. And I here you see v and u, the coordinates, so I have to write v and u again. U is our s 1 minus t and v is our 1 minus s. We have to put the limit seeing these two. So how can we do that? One simple thing is that assume that s is, I am doing this just to get the limits. Assume s to be sin square theta. Okay, and theta, and I already told that s and t are independent. So if you take t, then this will be in some other angle. So suppose this is cos square phi. Okay, since s and t are independent, so theta and phi will be independent. So this becomes sin square theta into sin square phi. Okay, and this will be cos square theta. Now why I have taken s equals to sin square theta? Because s goes from 0 to 1 excluding 0 and 1, and you know sin square theta also goes from 0 to 1, but there is a slight difference, and that difference is in sin square theta 0 and 1 is included. But as I said you that I am doing this only to make you understand about the limits. So obviously if you observe theta and phi are independent, so if you observe, then this will go from 0 to 1, also this one will go from 0 to 1. So limits for both the integration sign will be 0 to 1, 0 to 1. Now one thing I have to add in this, you see here in the black enclosure there is also pi square by 4 as a constant. So here I have to add that pi by 4. Okay, so I do here pi square by 4. Okay, now it is okay, and pi square by 4, and you know here will be if you observe this integration, I show you in black. Okay, if you see this one, then this will be this is the outer integration sign, and the value of the enclosed, if you see inside the enclosure, the black enclosure, the value of that will be 1 minus 1 by 2, and it remains now du. Okay, so here will be pi square by 4, and here 1 by 2 will come out as a constant, and integration du with higher limit 1, lower limit 0 will be 1. So our answer comes out to be pi square by 8, and this answer you see in option C. So C is our correct option. Okay, so I think this question is